I've chosen to make a video to illustrate chapter 4 in our textbook, How Can Parents Help Their Children Learn Math? I hope this will make it a little bit more fun. As you read this chapter, you should note the abbreviation EME. I'll use that a lot in the video, and it's just a common reference to early mathematics education. This doesn't mean a specific way of doing early mathematics, it's just a general term. And it specifically kind of refers to young children between the ages of 3 and 5. This chapter opens with some sobering statistics about young children in math, and actually even older children. One of the first things it points out is that by the 4th grade level, over half of children are deficient in their math skills in the United States, and only about 6% are advanced. And we really need to be thinking about what we're doing when children are young to change that. It goes on to educate the reader on the importance of a parent's role in EME to really change this. For EME to succeed, educators need to recognize how important it is. They need to understand why parents should be involved in it, and they need to know how they can get parents involved. So after the chapter introduces some of these statistics and gives you a picture of why this is an important issue, it delves right into why parents need to be involved in EME. So that's going to be our first point. One of the biggest reasons for this is that teachers of preschool and kindergarten age children seldom teach math. And when they do, it's pretty low quality. It's often just counting to 10 or recognizing numbers to 10. And there isn't a lot of more abstract thinking and just really understanding the processes of math. Second reason we need to involve parents is that statistics show that the long-term payoff for children whose parents teach them when they're young is really huge. One of the statistics it mentions is that for parents who engage in early number talk with children between 1 and 3 years, 13 to 30 months, they can see a positive relationship between that and children's later understanding of numbers at around 40 months. And then a third reason we need to involve parents is that they themselves often don't value math education in young children. They don't spend as much time helping their kids with math homework as with language arts homework, and other studies are really showing that it's not something that they value. Speaking of children, here comes my daughter Ivy. Hey Ivy! Did you have a question for me today?
Which one had more paint holes?
Which one has more holes for paint? I don't know. Can you tell me?
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8.
Oh, so which one does have more? That one does. This one has 8. My daughter Ivy is 5 years and 1 month old, and she actually asked me this the other day when painting with a friend, and she discovered that her paint palette had more holes than her friends. Thank you, Ivy. Thanks for sharing that with us. As you can see, as a parent, I didn't just answer Ivy's question and say, oh, yours has more. I asked her a question that both challenged her learning and her mathematical thinking, and it also let me know something about Ivy's understanding. She knew that even though these holes are smaller, and it might seem like this holds more paint, that when she counts them, in actuality, this has more holes, and that's a huge thing for a child to be able to understand. And that's it for our first point, and we'll move into our second point now about how young children are ready to learn mathematics. Okay, we're on to our second point, that young children are actually ready to learn mathematics. So once the book had shared some reasons on why parents need to be better involved in EME, it went on to show just how children are ready to learn about mathematics from a young age. It shows some special attention to socioeconomic differences. I won't go into all of that for time's sake, but as you can assume, children who are coming from lower socioeconomic backgrounds are going to struggle more and have less opportunities in the home to help them. A couple of things that points out is that children have core mathematical abilities from the time they're infants. It has some really neat things to say about that. And then it also talks about how throughout the preschool years, often even without adults' assistance, young children develop a comprehensive everyday way of doing math. They already begin to see shapes and patterns and think about numbers, and they do that without being taught specific ways to think about those things. This chapter gives a small overview of what those features are that children already have, but I'd like to highly recommend this book called Young Children's Mathematics for getting a deeper picture of this truth. I read this book last summer, and it revolutionized the way I think about math with young children. And I want to read a quote from this on page 93 of the book, and you'll be able to see the reference list on the video, just because I think it paints a really accurate picture of what this chapter is trying to get at. With traditional instruction, children first learn to add, subtract, multiply, and divide, and then apply the skills they have been taught to solve corresponding story problems. We recommend turning the process around, using children's intuitive problem-solving strategies to develop understanding of the operations of addition, subtraction, multiplication, division, before we introduce the formal symbols and algorithms. Several compelling reasons support this approach. First of all, understanding develops when new knowledge is connected to existing knowledge. Children can understand joining, separating, grouping, and partitioning before they're formally introduced to the mathematical notation that is used to represent these operations. It makes a lot of sense to build on this foundation. Furthermore, if the formal operations are not connected to these intuitive notions, there is evidence that children will construct two somewhat isolated systems of arithmetic, one that makes sense to them and that they use to solve problems in the real world, and one that they use for school mathematics that follows some seemingly arbitrary sets of rules. Another reason it makes sense to start with the strategies children intuitively use to solve arithmetic problems is that the general modeling strategy that comes naturally to young children represents a good general problem-solving strategy that's based on understanding the problem situation at hand. While the most serious difficulty that older children experience with arithmetic is applying what they know to solve problems, young children are actually pretty good problem solvers. If older children applied some of the strategies they intuitively used when they were younger, they would be more successful problem solvers. Too often, older children whose knowledge of addition, subtraction, multiplication, and division is not connected to their intuitive conceptions of these operations, when they attempt to solve problems by using strategies that focus on superficial features of problems, such as keywords or adding when there are 3 or more numbers in the problem, although these shorthand approaches or tricks may work in the short run, they often don't work in later problem solving, and they keep children from building on their own intuitive understandings. So anyway, that's a quote from the book. You're gonna wanna pick it up. It's really a great book. Oh, here comes Ivy again. I just wanna illustrate how children do have some of these ideas about mathematics. Ivy, we're going to the beach next week. It's gonna be us 6, our family, and the Mendozas. How many are the Mendozas? There are 3, you're right. So us 6 and those 3, and Auntie Wendy. So let's see. Can you count out us 6? Yeah. Us 6?
1, 2, 3, 4, 5, 6, 7.
That's 7. Okay, so 6 of us. And how many Mendozas? 3. And how many Auntie Wendy's? 1. Okay, so here's all of us going to the beach, but only 4 of us can fit in each of our cars. So we gotta figure out how many cars we need to take. Do you want to use these to represent cars? Okay, only 4 of us can fit in a car. What are you gonna do?
There's 10 of us.
There are 10 of us. You figured that out. Why don't you use these to figure out how many cars you need? So there are gonna be 4 of us in a car. Do you need more paper? Okay, grab more paper. So how many cars do we need?
3.
We need 3 cars. Thanks so much, Ivy. This interaction just showed what we were talking about. We don't think of a 5-year-old doing division with remainder, right? But they have natural proclivities for this stuff. It also shows how parents can bring fun and relevance to doing math together, not just with rote drills. We do this kind of thing as a family even when we're sitting at restaurants. The kids will sometimes ask me, Mom, give me a math problem. because it's a lot of fun. It's solving problems together. So yeah, that's a picture of that. We're now going to move into our third point. EME, what is it? Let's find out. Okay, for our third point, we're going to move into what exactly is EME. We're going to look at kind of two subheadings there. The first one is the goals of EME. I'll just start it so you know we're talking about it. The goals of EME are to prepare young children for later academic success in math. This is done by creating a firm foundation in their math understanding. It's pretty common sense at this point, I think, so that children begin to be exposed to math in school. When that begins to happen, they already have abstract ideas and understandings of what their teacher is talking about because they've done some of that at home or in preschool, and so it's not all this scary and new thing. The second goal is to help children enjoy learning math for the sake of math. Parents shouldn't be taskmasters giving rote drills, okay, let's do our flashcards, but they should bring joy and fun to math, and this can actually be a new experience for parents who maybe have fears and anxieties about math themselves. You saw what I did with Ivy. It's a great example of a goal of how we can make math fun. All right, and then let's talk about the basics of EME. Early math education is not just about learning to count, as is often emphasized in preschool and even kindergarten. It is about so much more. This chapter is this kind of section of the chapter is probably the most important for spelling out what the major aspects are of early math education. The first aspect is that early mathematics is full of content that's broad and deep and rich. The second aspect is that math is thinking. It's abstract, it involves reasoning, just like you saw Ivy with the very different looking paint palettes. The third aspect is metacognition and mathematizing. Metacognition is just a fancy way of saying that children need to be able to put their mathematical thinking into words, to explain it to others, to talk about it with their teachers. Mathematizing is being able to conceive of problems in mathematical terms. The final aspect is positive disposition. We cannot state this enough. A huge aspect of EME is helping children discover the joy of learning math. This is especially difficult when so many adults fear math and even say things like they hate it, or they're no good at it, or math is hard. We really need to change the way we talk and think about math. The fourth point in our chapter is how parents can help children learn math. We'll look at three subheadings: stimulating environment, supporting school programs, and home activities. The first point is a stimulating environment. There are many ways parents can provide a stimulating environment. I hope I showed that already with my interactions with Ivy. Books and simple manipulatives like buttons and paper are a great example. However, materials alone are not enough. We may be prone to buy things that seem mathy, but unless we're going to use them with children and show them how to use them, they don't really do anything, right? Parents need to help their children use them in meaningful ways. Parents don't need to have lots of money and be buying high-end Montessori toys. Shells, small stones, even paper can be stimulating if used correctly, as I showed. My children, as I mentioned before, often tore up pieces of napkin at restaurants to play games with while we waited for food. One of the books my preschoolers currently love is this book, Mouse Count, where a snake is after the mice, and you count the mice as they go in the jar. My preschoolers have always loved this book, but recently I brought down my son's rubber snake to our preschool, and we use little mice and a rubber snake, and we have a jar and a stone. These are all simple, easy things to find, and the kids love connecting manipulatives with books. Another great book, 10 Black Dots by Donald Cruz, has black spots on it, so you can read it with the kids, but they can also go back and put shells or stones on the black dots and do some of the counting themselves. There are so many great resources that educators can share with parents. The second thing parents can do is they can support school programs. Whoops. Our book mentions 3 curriculum options that involve parents and learning by making home and school connections. I'll list those at the bottom in the text. These include Big Math for Little Kids, Building Blocks, and Number Worlds. All of these include weekly letters that go home to parents about what the children are doing at school, and ideas for what they can do at home to connect home and school. And then the third thing, man, I'm really struggling with my stars here, is home activities. The third way that parents can help their children learn math is through home activities. This chapter mentions some specific resources for home activities, as well as mentioning games and books. I've pointed out a couple books as well. There's so many great math games out there, but also just a lot of things that you can create without expensive materials. The options are really quite endless. Educators can help parents by creating simple lists that will not be so overwhelming and not full of expensive things, but just quality materials like what I've hopefully showed you here. So, okay, the fifth and almost last point, we've got one more after this, that is seen in this chapter, is targeting language and ethnic minority parents. So it kind of goes back to just some of the struggles of people coming from lower socioeconomic status and what we can do to help in those areas. Chapter mentioned 4 ways to target language and ethnic minorities: Project Bridge, Project Maps, the Family Mathematics Curriculum, or also called FMC, and Getting Ready for School. The Getting Ready for School, when I read more about that, it piqued my interest, so that's the one I'll just go into detail a bit more about. I looked into it online, and it's designed to ready preschool children during the year before school enrollment. And basically what it is that older children in upper primary grades are called young facilitators, and they will be paired up with one or several preschool children. Teachers in the program are responsible for facilitating the group meetings, as well as guiding, motivating, and supporting the young facilitators, the older kids. Through weekly sessions in a school-based club-type atmosphere, the young facilitators engage children in a series of fun learning activities. Facilitators and their young children are encouraged to repeat and extend the club activities at home. I'll put at the bottom of the screen, you can see the website where you can access this. There's a free 72-page guide. It's copyright free. It can be adapted however you want for teachers to implement this program. It contains all the information for the 5 activity sets, and each set includes 7 group sessions. I loved how simple it was and how it encourages older children to scaffold the learning of younger kids. I'm actually looking into it as something that my older daughters, who are 12 and 11, and some of their friends could maybe do this summer in a nearby area where children live in extreme poverty, that we could do kind of a summer camp before they head into the public schools. So I would encourage you to check that out. Of the 4, that really I think is the one that has some great free, excellent, easy to follow, helpful tips. Our 6th and final point, roadmap towards the future. The chapter sums up with just some ideas for moving forward to supporting parents and children through EME. It involved 2 features related to a rich environment that we can provide. First, EME professionals can make an important contribution by developing programs and standards that are going to help parents so that they can evaluate the quality of materials that they purchase or use for their kids. So we can say, these are the things to look for. This is the type of materials you want to use for kids. Keep it simple, keep it cheap, but these are great. And second, EME professionals should develop programs to help parents engage in really thoughtful parenting that can foster their children's home learning. Just in the same way you saw me do with Ivy. If we can help parents begin to understand how to do that and how it's easy and how it's fun, we can really give kids a great start in their math education. I actually partly chose to do a video format so that I could allow this video to serve a dual purpose. It partly is a chapter illustration, but it partly hopefully shows how educators can make parents aware of what they can do to promote EME. Educators can make videos just like this, which show children asking mathematical questions, simple yet stimulating environments, simple ways that families of all socioeconomic statuses can make use of their resources. So I hope that this kind of showed that as well. When parents are helping their kids with math, they face 2 difficult issues, and that's kind of summed up in this last section. They need to know how to choose the right materials, and they need to know how to use them in a way that will stimulate a sense of wonder, engage children, and promote learning. The book refers to these as choice and magic, being the 2 difficulties. Information from educators presented in easy ways like this video can help parents work through those two issues. The book points out when speaking of a roadmap towards the future that parents can learn all this from books and the internet, doing their own searches, looking up their own resources, but schools are the best place for parents to learn. And I think as educators, we need to keep that in mind. We have a responsibility as educators to help parents understand the value for teaching their children math and to give them tools to do this so that they have a really great start and a great foundation in math.